Hi everyone, how are you? Thank you for participating in one more event of CaquiCoders. As we said before, 2 months ago, the CaquiCoders community, it's a Brazilian community, but we started to organize events in English to motivate developers, IT students to practice English in Brazil. But if you are not Brazilian and uh, you would like to participate, to send questions, and or even to subscribe in the YouTube channel of CaquiCoders, feel free to join us. And today we have two talks, one related to Blazor and IoT plus Linux operation systems. It's pretty new content. I would say is the first talk related to Blazor plus Linux plus IoT I have ever seen, because the Microsoft released the new features in Blazor supporting IoT recently, and I'm looking forward to seeing this talk. It will be the second one, will be made by Mateus. And the first one, it's about Phoenix framework. As, as you probably know, I'm a .NET developer. I have no idea at all what Lucas will talk about, but I'm sure that's pretty exciting. I will learn a lot about this stuff. Feel free to ask your questions in the chat on YouTube. If you have any problems with audio, video, please let me know in the chat during the event. Enjoy, and I will give the opportunity to Lucas to talk about yourself and start your talk. Thank you, everyone. Have a good presentation, Lucas.
Thanks, Alexandre. I would like to introduce myself. My name is Lucas. I'm a software engineer. In this talk, we're going to learn about Phoenix Framework, which is a Elixir web framework designed to build maintainable and maintainable software in a productive way, right? I would like to share my screen. Just wait. Share. Can you see my screen's share? Okay.
Yes, I can see your screen.
Great. As I said, my talk is about a brief introduction to Phoenix framework, and then we are going to understand how Phoenix can be used to develop uh, web systems and in any kind of software we can think of, right? As I said before, my name is Lucas. I live in São Paulo, in Brazil. I'm currently software engineer at Nubank, mobile bank based here in São Paulo, but we have offices in the Mexico and in other South American countries like Argentina. And today we're gonna at Nubank, we use mainly Clojure as the main programming language, but I have a background working with Ruby on Rails and Phoenix and Elixir code. So that's a great language and great languages that I like. Uh, and I hope you can get the most out of this presentation. And let's get started, right? Thank you very much. Our agenda for today is we're going to briefly I will show you how to build a simple CRUD application using the basics functionality from Phoenix. And by this doing that, we are going to understand the main features we can use to build a basic application. And I hope that after this presentation, all of you can will be able to build a more complex applications. This will be more. This presentation will be more to give you a solid grasp of how building web applications, right? So in this presentation, we're going to understand how request travels across our framework, across our systems inside Phoenix. We understand how we can use controllers, views, and templates, basic MVC application, right? We understand how Elixir implements the context for building our logic layer, right? And we understand about Acto, which is our persistence library that we can use it to persist our data into a database. So to start, I'm gonna show you how to install the framework, how to install, not how, but how you can use the documentation that Phoenix provides to install the framework and install the Elixir, Erlang, and all the procedures, right? Let's get started. First of all, I will hit the Phoenix framework. In this site, in this site, you can get all the documentation you need to install the Phoenix. One of the features I like most in the Elixir itself is the documentation system that the language provides. So every library in Elixir has a similar architecture for the documentation, right? In this documentation for Phoenix, we can learn how to install the Phoenix, how to configure our database, how to configure our Elixir in Erlang, and everything we need. So it's very, very easy to understand. And all of you, it's very, very simple, right? This is in the guides tab. It's like a tutorial that Phoenix offers to get our application up and running. So you can follow all these instructions. I'm gonna jump to how can we to create our application itself. So let's do it. I'm gonna open my terminal. Just here I have my terminal, right? We can build it. We will start by creating a Phoenix project. We can do this by typing mix ajax new, the name of our application, for instance users, which will be a user struct. This comment will generate all the scaffold application for us. We type Y to install our Nodejs dependencies. It's while it's installing. I don't know. We'll just install our dependencies. After that, after our application is ready to be running, I will going to show you how the folder structure that Phoenix offers to us, right? I hope my internet connection doesn't fail, and we're ready, right? After our scaffold application is ready, we can see some commands we can run to start our applications. We can enter into our folder. Currently, our comments we run before generated the application, generated the users, our users project, right? We're gonna jump into it. Users, and we have our application, all the files we need for application to be run. We're gonna run some commands here to to start. The first of all, we're gonna run mix acto create, which is a command to create our database. After all, I'm gonna show you how this command will create and which database it will be using, and how can we create new tables, etc. So for now, we just follow these instructions, right? This command is compiling our code, and we can see the message the database for users repo has been created, which means everything was fine. We're gonna run the second command to see if everything is okay. Mix pjax server, which starts our application. As you can see, our application is running on the port 4000. So let's go to that. Localhost 4000, and this is the first screen that shows the application is now ready to be developed, right? This is the first application. So I'm gonna open my text editor now. I'm gonna use Visual Studio Code. Let's understand the folder structure that Phoenix created for us. We have the assets folder, which stands for all the assets files we can use for our applications, like JavaScript files or CSS files, and the other files we can use for our assets. We have the config folder, which stands for every file that we need to configure our application itself. For instance, we have some structures to configure applications, like the URL that our application is running, and other things. We have our connection to our database, which generates, for instance, all the credentials we need to run in our application. We have all the configuration files for our applications to run. We also have the lib folder, which stands for the files that we'll be using to edit and create and develop our application itself, right? Later we're going to deep dive into the users and the users web folder more shortly. And we also have the test folder, which might be very clear. It's where we put our tests, right? Let's understand how Elix make a request, for instance, for now, right? First of all, I would like to give a small introduction to Phoenix itself. Phoenix is a web framework designed to give developers a more productive and maintainable way to create softwares. From Phoenix, we can expect everything we need from good framework, like a base architecture, a database management library, a routing layer, a flexible markup language, and user authentication capabilities and internationalization capabilities. To do all of that, Phoenix uses a convention over configuration to guide developers. These strategies has its benefits, like any developer that starts learning Phoenix will have a fast learning curve and become more productive and more easily. Since any Phoenix project has a singular architecture, it also prevents the developers taking informed decisions. So when we have the convention over configuration system, the convention over configuration pattern, like we can say, we spend more time developing our software than configuring our application itself, like boilerplate code, we don't need it, like configuring database, configuring the routing layer, all this kind of stuff is not needed in a Phoenix framework, right? And as you can see, we have a basic structure to start developing our system instead of configuring it, right? So for now, we're gonna have a simple application that will be able to to list users, to create users, to show a specific user and delete a specific user, for instance. It's a very, very simple application, but after that, you have a solid grasp how can we use Phoenix to build more and more complex applications, right? So let's get started and understand how can we implement that. First of all, let's see where we can put our routing systems, right? We have here the users web folder, which stands for every file that's related to web to web components of our applications. Like it's where we put our controllers, it's where we put our views, it's where we put our templates, it's where we configure our routing system. It's where we are going to do all the communication from our systems to the outside of the outside of the framework itself. For instance, I'm gonna create a route here for a test. Like, for instance, I have a route that hello, which can go to which we have a hello controller. And the action that will be used is index. Which it means? It means that when we type hello, localhost, hello, Elixir will match this route to this controller, a hello controller, in the action index. So it's like we have a controller here called hello controller, and inside of it we have a function called index that will return something. For instance, will render the page that show information, for example, that show a hello world. But for now, to save our time, we're going to implement our application, our sample application, right? To do that, I'm going to create a users, which will be routed to our users controller, and will match to an index action. I'll kick an action here. We create a controller called users controller, and with the every controller is nothing more than a module, a Elixir module. So so everything we does here, we are going to have a module and the functions that implement all the functionality for that module, right? So let's def our module here. Module. We were going to the users web and users controller. And to tell Phoenix that this module is a controller, we're going to use the controller system for our application, like users web controller. This line tells that this module is a controller for our application. We're going to have a function index that receives two parameters. When we type get users, this route will match to this action, right? One thing to understand in a Phoenix application is that we are going to work with context. Which is a context? What is a context? A context is where we encapsulate all our business logic for our entities. For instance, when we have a user registration functionality, it may be done in many ways, like password-based registration, OAuth-based registration, single sign-on-based registration, and so on. All these strategies are part of something we can call accounts code context. since they are all about user accounts. Our controller will interact only with our context functions, our accounts functions, for instance, instead of the business rules themselves, right? So that's why we're gonna use this module here, this folder, users folder, is where we are going to implement our account context. To do that, we just need a single folder here, like accounts, accounts. And inside these accounts, we are going to have our users files, which is user file, which is our user module, for instance. User. Yes. We can do this by module. User. Accounts. User. This is just for now. We are going to define this module as a struct, as a Elixir struct. How can we do that? Struct. In our structure, we have three fields: ID, a name, and an email. This module itself, this struct, will not be exposed directly to our controller. Instead, we're going to implement all our functions to interact with the struct in our accounts context. How can we do that? We can just create a file called accounts, which is our account context. F module. We can document this this module to tell to the other developers that this is a context. This is our context, right? So we can use the module doc. The account context. For now, we're going to have a simple function that will return all the users to be handled into our web browser. We can have the def, for instance, list users. We're going to return an array, a list in this case, because it's a list. But first of all, we have to import alias our users module. This line tells to Phoenix, to Elixir, that we're going to use the users module instead of writing. We can just type, for instance, user ID 1 name. Email. Don't save time and duplicate all this. Shall we? This this function does a simple thing. This return does a simple things. It just return a list of users. Just return a list of users, which will be accessible into our controller, right? So let's do it. I'm gonna save it. Users. I'm going to import users. Users. Accounts. We're gonna aliasing our accounts module. We have an error here, which is description name. See. It's incorrect. What's happening here? Description name is accounts. Users. Yes, right. It was incorrect. I just had to extend our code, our users module to be available in our accounts context. What this line means? It means that our user is inside the module in the accounts folder, which is this, and this accounts folder is inside the users folder, in users module, for instance. And we have the same pattern, the same name in our users, in our user module, for instance, right? So let's make our accounts context inside available in our controller. Users accounts. It's available now in our controllers, which means that we can just type accounts list users. By doing that, we can just render a view to show our users. For instance, HTML users. This line does a simple thing. It just searches in our view for a file called index.html and turns our users definitions, our users variable available in that view by just passing a keyword list, Elixir keyword list, telling that this user's key will be available in our view. To do that, we just need to create a template and create a view to handle all of our users, right? Let's do that. How can I say? In Phoenix is a framework that leverages the MVC pattern. For instance, the view in this case, the view that would be the V in the MVC, in Phoenix, we split the view into views and templates. The view is a module with rendering functions that transforms our data into a format for our end users, which can be HTML or a JSON file, for instance. A template, it's also a function that can be compiled from a file. And this file can contain a markup language with Elixir embedded code. For instance, we can have an HTML file that has Elixir code that will be replaced with data that we can pass through to this view, right? So that's where we're going to do a simple view here that just handles all of our users, that shows all of our users. To do that, we just need to create a user view. file. Review. Next. And we're going to tell that this module is just a view. Module, user, to tell Phoenix that this module is a view, we just have to use the view from Phoenix, from our framework, right? Use the view. Review. It's very, very simple. So we have an error here. Use. Oh. View. Use web view. Right. It's just incorrect. And now we are going to implement our template. Folder, users. We just have a folder here, and we're going to have an index file. This EEX extension tells that our file, our HTML file, is a file with embedded elixir. That's why the EEX stands for embedded elixir, right? So let's see if everything's working. We're going to have a hello world, for instance. One. Users. Routing. Users controller. Index. Let's see if everything's fine here. Users index. Users web. Let's see. So let's get our application up and running. Yes, meet server. All right. Let's go to our browser. We have a error here. Function will users view handler tools undefined. Model users web users view not available. What means this? Oh, we have a naming error here. We're going to rename it. User view. And now we have it. We have our users. So let's add some codes to handle all of our users. I read a message. Alexandre, the Rodolfo commented that my audio is not okay.
It's quite clear your audio to me. I'm just listening some noisy in the background, but your audio is pretty clear to me, your mic as well. So
I think it's because my notebook, because the fan is very loud here.
yeah, but at least to me here, it's not too bad. The audio, it's pretty the normal quality so far. Let's see if the quality gets worse or not in a couple of minutes. And we can take a feedback in 5 minutes to see what's going on.
Okay. let's see if it can be better. We're gonna be a little closer to my microphone, so we can comment if everything is it's good or not, right? Let's see. Let's define our let's render all of our users. Since it's a lot of code, I'm just going to paste some code that I have here to save our time.
For our, sorry, Lucas, for another user, the quality is good for the audio, so so nothing special, I think.
Okay.
I probably can hear you as the other users probably. So if your audio get lost or something like that, I will realize from here as well.
Okay. Okay. So let's continue. Paste my code here. I just have a table here with that has the fields. It has the columns ID, name, and email. That's the fields that we define in our user struct. This code here is embedded Elixir code, which means that we're going to do a list comprehension. That means that we're going to test to all users in the users we returned here for in our controller, right? These users is available through this variable here, users, and this for is just a list comprehension. It's just a for like any other language, in your imperative language, right? And for every user, we're gonna render table data with ID. We just render the name, just move this function. Let's see. This is another function that we'll cover later, right? User name, user email. We were going to render some links to see a user or to destroy a user, and that's all. Let's see if everything's working. So we have a error here, which means the path is undefined private. That means because our naming convention, so just have to type users here. And I have another error here, which is action show and not supported index. Great. This error tells us that action show is not available for our helper. That's because we don't have yet a show router to our controller. We can do this by just replacing our routing, making our routing a little simpler, right? We just tell, we just remove this get sources. Just use the resources function. Tell our framework that we have the users endpoint, right? This endpoint will be to our users controller. And to this controller, we're going to have the following actions, only the actions in this case. Index, show, create. For now, just these actions, because I'm afraid that I don't have time to show a complete build application. But later, I can do a specific talk to give them a deep dive into Elixir itself, into the Phoenix itself, to show a more detailed explanation about how Phoenix works. For now, this talk will be just a presentation, introduction to Phoenix, right? So we're gonna have just these actions, the index, the show, and the create actions. If we save this and reload, We have another delete action. This means that the delete action is not available. It could be done by deleting, but we're not going to implement the delete yet. So that's why I'm going to remove in our view the remove action. By doing that, it should be available, right? It's now rendering all our users that we created into our users module in our users module, right? So for now, we have a hard-coded users that return a list of users, but we often in a normal application we don't use hard-coded entities, right? We use a database for that. That's why Elixir has a library calling Acto. It's for our persistence layer. Let's understand what Acto is. Acto is the library for our persistence layer. It allows our application to connect to a database. In Phoenix, we normally use Postgres SQL, but there are some libraries that allows it to connect to any other NoSQL database like MongoDB or any other database. Acto has a feature called change sets. A change set is a structure that holds all the changes that we can perform in our database. A change set encapsulates all the logic of receiving data, casting it, and validating our fields and our data before persisting it to the database. We're going to implement our Acto. We're going to see that when we generated our project, it's Phoenix also generated our repo module that just tells to our application that we are going to use adapter for Postgres in our Actor library, right? So to tell our accounts context that we're going to receive data from the database, we're going to have to transform our user module into a schema that defines all the fields that will be available for that module or for that table. In this case, we have the fields name, ID, and email. So let's define our schema. We can do that by simply using the. I'm going to remove this def struct. It's no longer be a struct anymore. It will be, we're going to use the active schema. And we're going to import all the functions from change set. This code here just imports all the functions that are available in our the changes set module from active, right? So let's define our schema. We just use the schema macro and tell that we have the users table, and we have the field name, that is a string. We're going to have the field email, it's also a string. And we're going to have some other fields for our timestamp. I can use this timestamp function. The ID field for our users table is automatically generated by Act when we run a migration. That's why we're going to create a migration for our project that will create a table users in our database. I'm going to stop my code to running. Mix Act and this command here just generates a migration that will be responsible for creating our table into the database, right? Actor gem migration create users. It creates our database in the location in the migrations folder, right? Let's go to that. Prive repo. migrations, and we have our migration here. So let's write our code to generate our migration. Just have to type the following code. I'm gonna paste because I have a copy here, right? It creates the following. What this code is doing? It's just creating a table called users, and this table has the name field that's a male. It cannot be null. Also has a male that's string and also cannot be null. And the timestamps fields like inserted the ads and updated the ads. This function here will create the code get inserted at dated at, right? And we are also telling telling that our database has a unique index for our email. That means that email cannot be repeated, right? Two users cannot be created emails equally. So let's save. And we can perform this migration scheme. Oh, sorry. Next time. Sorry, instance. We're going to do it later, right? So let's run our migration. Mix, echo, migrate. And our table is created. So let's see if everything is working. To do that, we can use the following code. We can use the following way to add some users into our database. See, I'm gonna start a EX session here. Mix. It's just the command that I run right now is just telling that we're going to enter into interactive Elixir. It's just our REPL, just our command line to execute Elixir codes. To see if everything is fine here, let's just add some data into our database. That's why I'm gonna alias users REPL. Gonna alias also the accounts user. Okay. And let's insert a database, for instance. Let's insert a new user repo. We have this function repo insert. And this function receives a struct. In this case, is a user struct. Name, we have mail. Let's run to see if everything is fine. And if everything is green here, it means that our database is working and receiving data, right? It's persisting data. So let's add another data to facilitate our development. Okay. We're gonna run again. Until now, all our code that's being rendered into our view is coming from hard-coded list of users, right? So let's replace our context to get all the users from our database. To do that, we just need to alias users repo, and we just need to return people all. And we need to tell that we need to return this users module, in this case users users. And what this code does, repo all, the all function, it just goes to our database and returns all the users from our database and makes available to our module, right? And we are going to pass in here just a struct that means that we want to return all the users. If we have, for instance, a product here, this code would be returning a list of products if we have a products database, but we want a users, right? That's why we're going to pass the users module here, the users struct here. The schema also made our user module available as a struct that has the fields like ID, email, name, and all these timestamps fields that were available here when we executed the insert. It returned a struct with the fields email, ID, insert there, names, all the fields we want. And we'll have some meta fields, some meta tag fields, metadata, and tell that, for instance, tell the users this code belongs to the users table. And so the schema also maps our table to a struct. It's all what it's doing, right? So if we save, we can reload. Sorry, implement users. I have an error here. Let's see what's happened. Protocol not implemented. User. Set. Just it's not a map. It's not a struct that I had to pass here. It's the module itself that I had to pass here. I'm sorry. So let's save, reload it, and the code we inserted before is now present here, right? Okay, right now we're going to have, let's now implement, now we have our list function that returns all the users from database. Now let's implement an endpoint that returns a specific user by ID. How can we do that? For now, we're going to implement a function here that finds a user by an ID. For instance, so def find user ID, and we are going to use the function, the get function. And this function receives two arguments: the module that we want to return, and it receives the primary key that will be used to return the user. We have it, right? Now let's use our controller to make available this specific user in our controller. Remember when we implemented our routing in our routers, we implement the show action. This means that in our controller, we will have to have the show function to respond to this action. That's why we're going to show, implement this function. Show. This function will receive parent, receive a map ID, now to have our function implemented that it finds a user, we can use it. Okay. User equal to accounts find user, and we have an ID. Simple, and we have to render or com show HTML. It's very similar to our index action, but we have some difference. First of all, you notice that we have this second argument here. That means that we are going to have the pass the ID parameter. But how is this parameter being accessible in our controller? When we created our router, our user resource, this resource code, this resource function, generated some routes to us. For instance, let's see which routes it generated for us. Now, mix x routes. These functions list all the routes that are available for us. And as we can see, we have, for now, the only route that matters to us is these three routes here. We have a users that matches to a get message from our request, right? And we have the ID parameter here. That's exactly the ID we need in our controller, right? Just that. If we have a name, for instance, name, if our identifier was a name, for instance, we will need to update here to name, a name. It would be work, but it's not what we need, right? So let's see if everything's fine. It's raised an error, and I'll show you why it's raised an error, right? Let's see our page view index. You can see that we generated a link here that is used to us to access a specific user. It's an Elixir code that generates the link, a link tag that will how can I say, that will point to for this route here, users slash and the ID of the user. We have routes here, user's path. This user's path is automatically generated by Phoenix when we create our resource. So if we have a resource called products, we could access all the paths for that product, for the product resource, doing that, for instance, product path. But as we have just the user resource, we just need to type user. And this will generate the link that points to our users slash the ID of the user. So if I save, it's fine. So I have to start my server. And we have user's path. User's path, and before it was user. And it's live reload. Elixir has something called live reloading. That means when we save our file, it will be automatically rendered in our browser, right? That's why when I save, the screen reloads here. So if you tap here, if we click in this view that's generated by this function here, we have an error. This error tells us that the show file, the show HTML cannot be rendered, which is fine because we didn't create it yet. So let's create it. We're going to use the same folder in the templates folder. We're going to create the show HTML. Next. Let's see if it's fine. For instance, one. User. If we save, library loaded, and it's fine. Now we have to show the information for our user. We'll be simple and paste some code here since it's very, very simple. Let's name. This syntax here stands for to execute a function or a code and render it and render the result of this function, right? The result of this code. That's why our user is available, for instance, name. If we save it, we have our name available here. Let's do another ID, and we have our email. It's available here, right? It's very, very simple, as you can see. So now let's add the last functionality for our code by creating a form to create new users. How we can do that? First of all, I will go into our index file, create a link, link new user. And this link will path to browse user's path. Path new action. It will probably raise an error because we don't have the new action available in our router. So if we type here, as expected, we have new. We just need to go to our router and make the new action available. Simple. And now, when we click, we have an error. That means the user's web user's controller is undefined. That's fine because we don't have the new action available in our controller. We're going to implement that. Here. Syscom parents. This syntax here, this is a convention that says we're going to receive parameters, but we are not going to use those parameters. That's why we put underscore before. Just the convention, right? And let's see that some minutes ago, I said that Elixir, the actual library offers something called change sets. The change sets, as I said, is a structure to hold all the changes in our data, to hold all the changes we can make in our data before persisting it. We just need a change set here because we are going to create a new user. When we are going to make it available in our form to be rendered in our form. That's why we're going to create a function called change user or new user to become more simpler, simple counts f new user. And this function will receive as parameter a struct, map in this case. And we need our change set to be available in our user module. How can we do that? We just need to define our change set function. change set, the user, some attributes. This change set will receive a user as parameter, and it will receive a second parameter in a list of attributes. Keyword list of attributes. We're going to use the pipeline operator in Elixir to describe the changes, the validations we will need to do in our user. For instance, the cast function here's name a list mail. We're going to validate required. Mail. Validate length. This change set function does something, does the following things in our user module. It just requires the names, the attributes names, name, and email. It validates, it just performs a validation to verify if our name and email are present, if the user typed their name or their mail, and also validates the length of our name, which cannot be longer than 30 characters, right? It's very simple. For now, it's just like a magic, but as we are going to learn more and more about Phoenix and more about Elixir, you understand that's happening here is just a function chain. In Elixir is called pipeline operator. That means take this parameter, take this user, and passes this as the first argument to this function cast that's coming from the change set module. This cast, this validation functions, all these functions are coming from the change set module, right? And what is saying? What's happening here is we taking this user argument and passing it as a first argument or something like this. This could be done in the following way. For instance, cast user. But as a pipeline operator, it's just passing the first argument to the function, and the return of this function is being passed as the first argument of the following function, and so on. Let's remove it. But this way is more simpler to read and understand what's happening here. We are just requiring the name and the email, validate the required fields, and also validate the length of the fields, right? I'm gonna save it. And I'm going to make this function, this change set function, available in our account context, right? User, change set. User, attributes. Since it's a new user, I don't have any attribute yet. So we pass an empty map here, right? Because we don't need it yet. Let's see, change set is available here. Now we're going to our controller and implement this function. Change set. Counts. User. We need to pass a user's map here. That's why I'm going to use pass the map itself. accounts user, and we're going to render our new file. In the set. We save it. That our render new is not available because we didn't create a new file yet. So let's do it. New. Oh, sorry, I just need to name X, right? I'm gonna paste the form that I have here to save our time and explain what's happening. In this file, in this new file, I have the following. I have a Elixir code to handle our form. For instance, I have this function form for, which takes our change set, exactly the change set we return here, we define it here. This change set, exactly this one. And this form for, since it's used for post action, we need to define the route that the URL that will be used to post our data, right? To send our data. This route user path, you just need to create, our create route, right? It will not be available yet because we didn't define in our router file. Let's make it available. Create. Oh, it's available. Sorry. It's available here in this case. Huh? So it's available. What more? Let's here. Page path. User's path. And we have something happening here. Something is happening here. We're rendering a text input and a email input, right? We have this error tag here. That's because if a user don't type a name or don't type email or type a long name, this error here will be rendered telling that this field is incorrect, this field has an error, and the user must correct it, right? And also we have this submit function that's used to save our, to send the user to the backend, to our controller. Let's see if everything's fine here. And voila, it's fine here, it's rendered. If we type here, we have an error because the create function is undefined, our post function is undefined. So let's create. When you hit the button save, you didn't find our action, so let's create. It's the last step for our code. Def create. Com. User. User parents. I'm gonna paste some code here to save our time. What is happening here? In our accounts context, in our accounts module, we will have a create user function that receives the parents that the user typed in the form. And if everything's okay, if the user could be created, it will redirect our index path with the message user, the name of the user created. For that, we have this con that we saw a lot here. That's nothing more the representation of our connection, of our how can I say, all the steps all the steps that request must perform. For instance, we put a flash and use the result of this flash to redirect to our path, our index path. This con is just a representation of our connection. It's very simple. It's a more simple way to explain this, but since I don't have much time here, I'm going to have in the future maybe I will have a specific presentation to explain how the things works in the works more deeply, right? So we have a create, we're going to implement, but if something happen, if ever happen, we'll handle our new action with the errors being handled, right? So let's implement our create user function. I'm going to save more time in here and paste our code. Code create user. Accounts. This create user function just received attributes the user type, returns the change set for that user. In other words, performs all the validation in that attributes, all the information that user provided. And if everything's fine, it just insert it into database, right? Exactly what's happening here. So let's see if everything's fine here. First of all, we try to persist invalid information. As you can see, we have the message here that can be blank, can be blank. That's because in our view, let's go there, view, which means change set action, which means that if we have this action argument, this action key, it means that something went wrong. So that's why we enter this message here, and also the errors here, right? So let's save a new user. .com. Let's see if everything's fine. Sorry, we have an error here, user path. Oh, because in our controller, spell users. We handle here. So let's here. We have an error here because the index, we already perceived the Mateus data. So it's conflicted. So let's see, create another email here. Souza. Save it. And Mateus Souza is already persisted, right? Blah, blah, blah. Let's see another blah, blah, gmail.com. Save it. And we have it here. If we go here and see, our partial CRUD is already working, right? So it's I think this talk was I passed a lot of content here. Maybe you didn't get all of the things that I told you here. Maybe there's a lot of things that I would like to present to you, but unfortunately I don't have a lot of time because it will require more and more time. And but I hope this talk, this presentation, could give you a solid grasp, or how can I say, an intuition. How can we use our Phoenix framework to develop applications? Phoenix has have amazing features like live view that can be used to make some animations, make real-time applications that, for instance, a chat application or even a game we can design using Phoenix framework because of the live view that allow us to perform some visual effects without writing any line of JavaScript, for instance. That's probably the live view is something that I can, in a future talk, I can explain how we can use it to how can we can use the live view to make our application more to give to our users a better user experience. How can I say? But for now, I hope this partial code could help you to make a simple application, but also can give you intuition how can we use to develop more complex applications using Phoenix, using this amazing framework that's available for us, right? Alexandre, I'm finished now. I passed my time a lot here, but
Okay, no problem. Thank you, Lucas. Great presentation. I think it was really useful to understand what Phoenix is, what Phoenix can do for us, and even for non-broad or related technology developers. I think could understand how it works. And one interesting point here, in my opinion, is Microsoft technologies, Java frameworks, and Phoenix has all of them have similar architecture. That means if you learn properly MVC, design patterns, architecture, object-oriented concepts properly, you will be able to learn new technologies, new languages, new frameworks easily. And that's kind of a requisite for modern developers, because if we take a look like 10, 15 years ago, it wasn't pretty common to have a developer who uses more than one technology, or that it's specialized in more than one technology, like only C# or only Java or PHP or other technologies. But it's becoming more and more common in the market to have like a multi-language developers, because the environments in the companies are pretty diverse. So we have in a single company many applications developed using many different technologies, and because of that, it's really important to learn constantly new things, Nodejs, C#, Java. But the most important thing, if you know or have a strong knowledge in one technology, you can adapt easily to another one. And I think it's the Phoenix framework and related technologies are pretty interesting to learn. And can you talk to us about the market for developers in Brazil, other countries in general?
yes, Elixir is very used in the Europe markets and the United States markets. Here in Brazil, we have some companies that using the Elixir too. For instance, we have a company here for real estate that's using Elixir for a long time. In the United States, we have companies like The Real, Bleacher Report. We have even a games companies using Elixir, like Square Enix is using Elixir in their backend. So Pinterest is using Elixir too, and a lot of developers in Brazil works remotely for these companies. So the marketing for this language, for functional language in special, are very open to very vast for new developers, right? For developers who know the functional language like Elixir, like Clojure, or even other languages that are not originated like a functional language, but also implement some functional concepts like C#, Java, JavaScript. All these languages, the the functional paradigm is becoming more and more popular, right? Nubank, for instance, since the first day, since the first day, used the Clojure as the main programming language. Which is a very modern language. It's a very familiar language who for who already is familiarized with Lisp languages and so on, right? So the marketing is very, very good. The salary for these languages are extremely high too, because we have few developers who knows these languages, who know the functional paradigms. So the salaries increase dramatically. So it's a very good way. Elixir is a very good first start for new developers who are coming from object-oriented to the functional programming. Elixir is a very friendly. It's a lot of things that we can use in Elixir. It's a very familiar. The syntax is familiar to Ruby also. So the market is very good, and anyone can learn. Anyone who desires to go to the functional can learn. For Elixir itself, for the Phoenix framework itself, there are some books that I would like to recommend. For instance, the books Programming Phoenix. We have this book. It's a very good to understand the framework itself. It's the book that I read to do this presentation too. But before learning the framework itself, we need to learn the language first, right? We have also these books, the functional programming, Elixir, Oh, sorry. This book was written by my colleague, Ulisses Almeida. It's a very good book to start learning the functional programming. It's a very easy, we can understand more and more about Elixir. And if we learn the Elixir more deeply, to understand about concurrency, to understand parallel programming, and other stuff that Erlang itself provides to us through Elixir, we have the book Elixir in Action. This book is one of the best books about Elixir, about functional programming. It's we understand about parallel programming, we understand about concurrent programming, and all of that with using the Elixir and the Erlang behind it, right? So it's a very good way to start learning, to become more familiar with Elixir itself. So these are the recommendations that I would like to give. So feel free to, if any of you would like to learn. So that's it.
So thank you, Lucas, for who will watch this presentation after that, because it will be available on YouTube after that. So feel free to connect with Lucas. He is one of the organizers of CaquiCoders, so you can find him easily on Meetup and LinkedIn as well. He will share the presentation in Meetup, in the Meetup, I think. And
very simple. I don't know if it's a.
Oh, just to share your contacts there. So,
Nice.
So, and thank you very much, Lucas. Great presentation. The next talk will be with Mateus. Everyone who knows me are sure that I am a Blazor enthusiast. I generate a lot of content related to Blazor, and I use Blazor since its first version. So I really exciting for the next talk. Thank you, Mateus, for participating in CaquiCoders event. It's our first contribution to the community. So thank you very much. Let us know if you can hear us correctly.
Yeah, you are hearing me?
Yes, yes.
Okay, and the video is good too. You are receiving well to video.
Yeah, sure. So your presentation can start. Thanks so much, Lucas. For who is watching, if you have any questions, leave in the chat, and I will ask to Mateus the questions as far as I can. Have a good presentation, Mateus.
Okay, thank you. First of all, thank you, Alexandre, for the opportunity to stay here. I had some issues with my internet connection here, but I think we are stable now. Thank you, Lucas, too. So let's start here. Alexandre, you can put myself on the big screen, or
Let me see if I can do that. Can you talk?
no? Hello, 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 hello.
Can you hear me?
Yeah, but
So if you share your screen, can you share your screen? I think the focus on the streaming will be
let's
on who is
try.
talking at the moment. So
Yeah, let's try enter again with the other camera.
okay.
Okay.
So let's wait a little bit. So we have a plan to make these events in English each 2 or 3 months, and the idea is to bring international speakers as well. In the first 2 events, we are taking Brazilian speakers because we are trying to get the best formats for these events. But for the next events, the call for papers will be open to international speakers. That's the idea, to mix Brazilian speakers with international ones. But if would you like to speak about something in the next events, feel free to submit your talk. Even you don't have experience, make presentations in English. Don't be afraid of that, because everyone got a little nervous in talks in general, even experienced developers, speakers. So no problem. If you don't have experience with that, we can help you to make the presentation, to train yourself, to get yourself ready for the presentation. I think Mateus is back.
Yeah. Now with the screen shared. Yeah.
Yes.
Okay.
Yes.
Okay. Because I had here a plugin that make composition between all my cameras, because I have a camera here in my front and a camera for my desk with the boards, the embedded device. So
Many tricks made by who loves IoT. I don't have many cameras.
yeah, but I have to show the embedded devices too. So I will try
Yeah.
to share the cameras at the moment. So okay, let's begin here. I will talk about Blazor for IoT and embedded Linux device. Is a pretty new thing. The Blazor itself is a new technology on the .NET Core ecosystem. So I will present a proof of concept of use. We are not using this on the market right now. This is a proof of concept of using Blazor for the remote user interface, and at the same time the same page, the same Blazor page for local user interfaces. It's something like when you have a modem, an internet modem. you had that web interface to change some features and configurations of your modem. This is a remote user interface. And for a local user interface, you expect to have a touch screen on the device to change the same configurations and etc. So this is a proof of concept to use this. I will present to the .NET IoT project. That is a project from the .NET Foundation for access interfaces and devices on embedded Linux. Okay, so for who don't know me, I'm Matheus Castelo. I have 29 years old. I'm graduating computer science, and I work as embedded software engineer since 2015. And actually, I work on Nodejs, that is a manufacturer of computer modules. I had some contributions for the kernel Linux. I'm a kernel Linux developer. So I had these contributions for the Linux Torvalds project, and also I had some contributions for the .NET IoT that I will present today. So, and I have two YouTube channel. If you like this kind of content about embedded systems, I have this YouTube channel, youtube.com/Micro Hobby Brazil with S. It's not Brazil with Z, Brazil with S. Okay. Let's go ahead. So first of all, I have to leave a disclaimer here. I'm not a Microsoft guy. I'm beginning on this ecosystem from the .NET Core now, but I have some experience with the Microsoft .NET framework and Visual Studio because on my college we had that Microsoft Students program. So the teachers are encouraged to use the Microsoft technologies, but I always try when at the time at college I always try to use the similar and free and open source technologies like Mono and Mono developed. That is very buggy at the time, and I don't know today, but it's the best way to work with the Mono framework in Linux that time. But these things are changing. Microsoft loves Linux now. Microsoft is releasing a lot of stuff as open source, contributing back into kernel Linux itself, and now we can use all these technologies, all these Microsoft technologies, in .NET Core ecosystem. .NET Core is released as open source as well. So we have the Visual Studio Code that is an awesome awesome IDE with very cool extensions. So we have the Docker running on the Windows. We have now the Windows subsystem for Linux that ship kernel Linux inside the Windows to use inside a Hyper-V virtual machine. So Microsoft changed the way to release software, changed the way that they are developing software, and this is very cool. I'm very excited to work with these technologies today. So let's talk about the hardware and the Nodejs. Nodejs is manufactured, but it's manufactured about this kind of embedded systems. As you can see here, this is a computer module. This guy first appearance appeared to be a memory, a RAM memory, like no. So for PC, but it's not. Here we have all that is needed to a complete computer. So here we have the processor, dual core processor. We have memory, RAM memory. We have storage memory. All this in this PCB, in this board here. So this project designed for make this kind of embedded system is very hard. You have many layers of project and design all these high clock signals, so it's not easy to project this. So Nodejs design and project this and manufacture and sell this, and so we can use this in a baseboard that is this board here. And the baseboard with the computer module is like a computer, a single board computer, like Raspberry Pi and others single board computers. So in a hardware perspective, manufacture and project and design, the baseboard is more easy. You don't have so many layers, you don't have so many signals and everything. So for your product, for project your product, you can use the computer module and made your baseboard more easily. Okay. Here for the demonstration, you do not use this specifically this hardware. I use other hardware. I will try to share here to. Yeah. So we had here the Apollo ZMX6 is other hardware. Is what kind of computer model is very it's close, appear to be like the one that we have on the slide, but it's more powerful. This guy here, we had a quad-core processor. So you can see his computer model here. I can detach here. Okay. So we had all these that components that I talk about, the memory, the RAM memory, the storage memory, the processor, and everything that you need to run. Oh, you're trying to put on the big screen?
Yes, and I'm failing. So keep going.
No problem, no problem. And this we can attach on the baseboard here, and we had a single board computer. So this kind of form factor that we call is very cool, because this guy here, we had a quad core or a hexa core processor. But if you had a problem that do not need so powerful, you can change this for another with dual core or a quad core or less memory. This can fit specifically and optimize it for your problem. So let's continue here. Okay. Let's put my camera back. Okay, so let's develop something. Let's program something using .NET Core for an embedded device. First of all, let's develop a simple hello world. Okay. We had some challenges to develop for embedded device, because as I show here on this slide, we had in our development PCs, we had architecture that is Intel, is x64 or x86 Intel processor, and we had a package. We had a .NET Core application that have to be deployed on our ARM architecture. 99% of embedded devices for that runs Linux, that is microprocessors, and runs ARM architecture. So this is a challenge. We had to cross-compile this application. We had to deliver a cross-architecture package for run on this kind of device. So here, let's show here first. Here we have a main program that will print the runtime operation system architecture for us. You print here for us what kind of architecture the processor that the runtime is running, and the operation system description and a hello world at the end. So if I enter here .NET Run, I am running in my Windows. So I expect to receive here Intel Arc x64 and in the OS description, yeah, right, the Microsoft Windows 10 and hello world at the end. Okay, it's working. But now for run on the Linux or run in a Linux running a different architecture, we had to run the .NET publish with the R argument. This R means runtime. So I will pass the runtime platform and the architecture. So to run on a Linux, I can .NET publish R Linux x64. So the .NET SDK will compile and made all the dependencies to run my application, my Hello application here for Linux in a x64 architecture format. It's okay. So I have here two terminal running Debian on a Windows subsystem for Linux. I am here on the same folder, so I can now run the application, the Linux x64 publish hello. And now we expect to receive the same architecture. I'm running the same processor and the same development PC, but the OS description will be different. And of course, we are running now an ELF executable on Linux. So yeah, we receive here the Arc x64 and a Linux 4.19. Okay, so this works, but we are publishing a package for Linux x64. For deploy this package on the embedded device, for ARM embedded device, we can use the .NET publish R Linux ARM. Okay, if you are running in ARM v7 that is 32 bits is Linux ARM, but if you are running in the ARM v8 that is 64 bits, you can pass the Linux ARM 64. Okay, so in our case here, I'm running Linux ARM 32 bits. So you .NET publish for Linux ARM. This will compile and make all dependencies for Linux and for ARM architecture. So, okay. So you can see here in the folder Linux ARM. All the dependencies, all the DLLs that is made for run or applications. So in the publish, you can get all this file. You can copy all this publish folder and copy and paste on your deploy target on your embedded device to run this for ARM architecture. Other cool thing is this utility on Linux. We have file utility that we can pass here the binary, and we can see the header type of the binary. So we had here on the hello binary that .NET SDK built for us. We have a ELF 32-bit executable for ARM architecture. So it's okay. For save my time here, I already copied this publish folder for my embedded device. Here I'm connecting through SSH, my embedded device. So I'm not you show the board right now, but it's running on the device. If I use other utility here, you can see the arc utility will show us the architecture that Bash is running. So we are running on ARM v7. So this is connected on the SSH of the embedded device, okay? So we can run publish hello. Oh no, we had a problem. As you can see here, we don't have a valid ICU package. This is another challenge for develop for embedded devices. Here on the publish, we had out DLLs, some share objects to work with, dependencies to run our application, but we are missing yet one dependency. So for desktop environment or web environment, we had some distribution, some Linux distribution, and we can easily made apt-get on your Bash and install this kind of dependency. But for embedded devices, you can see here on my distro, I don't have apt, I don't have any kind of package manager to install this dependency. My board here, I use my board here. They had 4 gigabytes of storage memory. So for embedded devices, we had some limitations. We have minimal hardware for run a specific application. So here we have 2 gigabytes running 4 gigabytes of storage. So the distributions, the Linux distributions that are made for this kind of embedded device are made from scratch. So we get all the dependencies for running your application, make a recipe for this, and build from scratch. The kernel, the drivers, and everything to optimize your storage space. Okay. And so if you need some dependence, for example, now for run our application, we need the ICU package. We have to put this ICU package in our recipe and build this, cross-compile this for the ARM architecture for input this on our distribution. So one way to solve this is using Docker, but Docker inside the embedded system. This is kind of new stuff too. This is gaining ground now into market. But maybe you are heard of, for example, the Red Hat Core OS or the Ranger OS. This kind of Linux distribution that comes with the minimum to run a Docker runtime, for example. And this is gaining a ground in the embedded systems market too, because the same problems that we have to make the development environment, the QA and test environment, and the deploying environment you had on the embedded device. With the plus of this optimization that we need to do to not spend much storage memory. So what we are doing in Toradex, we are developing distribution, a Linux distribution that we call Horizon. Is a minimum Linux distribution made from scratch, but with the minimum and dependencies to run a Docker runtime. So we can deliver a Docker image for ARM architecture to run, to deploy image on at the edge. So this is very cool. For example, I will run now. We have here our Hello World project, okay? And here I wrote a Docker file for this. So we can see here we have multi-stage Docker file. Here we have the development environment. I'm using a .NET Core SDK container image, Docker image as base, and call this as build here. So here I will copy the project, copy all the source files to inside the container, and we'll run the .NET build and publish for the Linux ARM. So in this step, in this stage, we will create and build the binary on all the dependencies of our hello application. And in the second stage, the deploy stage, that is the stage that will compile and that will bundle our Docker image. We can see here that I am using an ARM 32v7 image from Debian, Buster Slim as deploy. So here I am installing for ARM 32v7. I'm installing here the library, the package that we are missing, the libicu. And so I can copy the artifact, I can copy the binary that build stage compile for me, and all the dependencies. The two is I'm compiling all the publish folder for inside from the build stage to my second stage here inside the project folder. And at the end, I'm running our hello binary, running our application. So to save time, I already build this Docker image, and I will only run. Oops. I will only run this. What? What's happening? The keyboard language changed. Oh, okay. Okay. So as I said, I had here Horizon installed on my board. I'm here back on my embedded device that is running ARM v7 architecture. I had this Horizon distribution that has a minimal Linux distribution with only the Docker, so I can run here the Docker, run IT, and the image that I push for the Docker file to Docker Hub that calls .NET ARM hello. So I already pulled this, and this will run. You can see here is running correctly with no problems. Of course, we installed the lib that was missing and delivered this application in a Docker image. So this solved the problem. We can now deliver an application in a Docker image at the edge for embedded device. So we can see here the Arc, this Arc ARM, and the kernel Linux, the version of the kernel Linux that I am running here on my embedded device, and hello world at the end. So it's work. So we solve one challenge for development of embedded devices. Okay, so the .NET IoT project. .NET IoT project. Let's show the page of the GitHub here. So it's here you can access the .NET IoT project and all the source code is released as open source tool, is inside the .NET platform GitHub project. So it's .NET IoT here. So in the description, you can see here, the .NET Core can be used to build applications for IoT devices and scenarios. IoT applications typically interact with sensors, displays, and input devices that require the use of GPIO pins. So the .NET GPIO have a lot of interfaces and APIs to access GPIOs, the pins of our boards, the input-output pins of our boards, to activate some lights or motors or other peripherals. Okay, and the .NET IoT have this system device GPIO namespace for GPIO, PWM, and E2C interface, and to the IoT device bindings namespace. This is very cool because we can access here the source devices. The IoT device bindings have a lot of peripherals, a lot of sensors, a lot of devices already implemented. So we can, for example, the DAT. This kind of temperature and humidity sensor is very popular on the maker world. So we can use the system device, GPIO, and the IoT device bindings very easy, only entering or writing a new DAT11. And with this instance, we can access the properties, the temperature, the humidity, and it's very easy to access. Is already implemented this kind of device for you. And if you had to access other devices, screens, or other things, we have a great list here already done, already implemented for your project. Okay, go ahead. So the main idea is use the .NET ecosystem, the .NET software ecosystem in all the stack for IoT, because, okay, I'm talking here about IoT, but I'm focused more on the think part, on the development of the think part, but we have to the Internet of Things, that we have to have an infrastructure, internet, networks, and the cloud that consumes and processes data, the edge that is acquiring this data and everything. So the idea with .NET IoT is use .NET Core tools at the edge from how, and use the ecosystem now, the IoT stack. Okay. I will exemplify the .NET IoT on the proof of concept on the demonstration, okay, for the Blazor. Okay, but I will talk about Blazor, right? But what about the user interface? As I said on the beginning, we have this architecture, this kind of a local user interface and remote user interface in device and in the embedded device. For the user interface for local user interfaces, we had some solutions. We had some platforms, some frameworks to do this. WinForms, but WinForms in Linux, we can use the monoforms, but this is a pain because this will work with the .NET Core standard, but we had to compile it and made some tricks. And the monoforms don't have auto implementation from the Windows forms. So yeah. Okay, the next one is the GTK Sharp. This is very popular one. We had some very popular programs made for Linux that use, I think GIMP, that is a very popular similar project similar to Photoshop, that use GTK Sharp for the user interface. And guys that are users to GTK in Linux can be very easy to use too. We had Qt Sharp. Qt is a very popular user interface framework for embedded devices, optimized for embedded devices, and we had some bindings for the C Sharp. To be honest, I do not play much with this kind of bindings. And we had two Xamarin Forms with the GTK backend, but to be honest, I never put my hands on code with this Xamarin Form, so I don't have much to talk about this. And the solutions we had for the local user interface. Okay, I don't know if as a way to transform this in a remote user interface. So if we choose one of these to make our local UI, probably we will have to choose a web framework for do the remote UI. So why not create a web app for access or for make the local UI and the remote UI with the same page as said. So for this, we have the ASP.NET project and the Blazor. So for the first one, the ASP.NET, for the remote user interface, I think it would be a good idea. But for the local user interface, I don't think so, because when we have a local user interface, you are expecting to have some more reactive, some and touch screen, and you touch on this react very fast with the changing the state of the components. So in the ASP.NET, maybe we have some delays by the HTTP requests. But for the Blazor, this is not a problem, because they runs the WebAssembly or SignalWare. This is very fast and very reactive. The user experience for local UI is great too. So let's go ahead and try Blazor to try this local UI and remote UI with the same Blazor page. But one thing that we can be concerned is about the two ways that we can create a Blazor project. We have the Blazor WebAssembly and the Blazor server, right? For embedded devices, for embedded Linux devices, the Blazor WebAssembly is not a good idea, because, okay, we are running this inside a sandbox, inside a browser, and that have the WebAssembly API and everything running in a sandbox environment. So this WebAssembly will have access to the board peripherals and board devices. Okay, so this is closed by a security design. But on the other end, we have the Blazor server type. So on the Blazor server, we are running the Blazor server, okay, and the browser connects by a SignalWare, and the server side can have all this ASP.NET Core runtime running, and all the access that we have for peripherals devices and the board resources, we can do it. So the best way to follow for embedded devices now is the Blazor server way. Okay, so we can connect our LEDs, lights, motors, and everything using the .NET IoT project. Okay, so the proof of concept here, I'm running on Horizon, on our distribution, on our Linux distribution with the Docker runtime, and I'm running some kind of microservices at the edge here. I have three containers, because first of all, I'm not running nothing, only the Docker runtime on our board. So we need first a desktop environment. We are running here a container with the Wayland Weston for the desktop environment. The Chromium needs a desktop environment to run. So because of this depends of the Wayland compositor and the Weston desktop environment. And Chromium, you will open in a kiosk mode. This is a page, it's full screen page with no decorators, only our Blazor page for the local UI. Okay, and we have to a container with the Blazor server running that will serve our remote user interface and our local user interface. Okay, So it's the demo time. Oh God. So I'm back here on my SSH on my embedded device, okay? Let's go to Rome to Horizon, where I have the Docker Compose. So I have this Docker Compose here. This Docker Compose, I will run the Docker Compose up. This Docker Compose have all the rules and all the commands to up my microservice application without containers and all the dependencies to run correctly. So I will share my camera on the desk. So you can see the application beginning to run. We are with our desktop environment Western running. The Blazor servers is already running too, and Kiosk is the last container to run. And now we have here the Blazor page running, the Blazor server page running. The Kiosk, the Chromium Kiosk open our connection on the Blazor page. And here we had some comments. Alexandre,
Yes.
You could try to put this on the.
Let me see.
Maybe if I stop the screen.
Yes. Let me see here.
Yeah, it's better.
Yeah, it's not so good. Can you speak? I will mute myself and maybe only yourself will appear.
You will hear me? I'm only seeing your screen.
So didn't work. I think that vision is the best we can do.
Okay, no problem. I will show to the remote UI, so it's no problem. Okay, so let's continue here. So here I have the Blazor page. Okay, the index page here. I have two buttons. These buttons will activate here. Will change the state of these two LEDs here. So if I press the blue button, we will turn on the LED, the blue LED, and same for the yellow LED. And the response here is very fast, it's very reactive, the user experience is very good. The same here, I have a donut component in this donut component. I have here on light sensor. This guy here. I have here this light sensor, and this light sensor is showing on the donut level of the light on my environment. So if I do this, you can see the light level decreasing on our donut, and if you can see the increase of the light level. So the reactive is very good. And all of this with on a Blazor page. But let's share screen again. Okay, thank you. Now I will show this running together with the where is yeah, here. So now I'm accessing the same Blazor page, but now on my browser, on my remote UI. So we can expect that you pay attention here on my camera. Okay, so if I change the state on my remote UI, the same will share on my local UI. Because we are sharing the same component, we are sharing the same singleton object. I will show this in the code. This is very cool because we had this signal error between the server, and the server is sharing this instance of object. So we can use this in different sessions. Here I'm here on my computer, and my accessing the remote UI, and this change, if the same happens if I change here the state on the local UI, we can see this being propagated to the local UI. The same thing with whoa, we have a bug. Oh no, it's working. Okay, so let's talk script. Let's see the code. How this is made, and this is some tips for developed for embedded devices using the Blazor, because on our example here, we are using some devices that are unique on our embedded device. Here on configure services of our Blazor project or startup C#, we can see here some services adding singleton services. Okay, so one of these services is the GPIO device service. So let's navigate to GPIO device services. So you can see here that I'm using the system device GPIO and using the system device GPIO drivers. For example, you can think about if you have some system for automation your home or a smart home, and you have to turn on a light on your home on somewhere in your home. If you do this on the local UI, this has to be propagate on the others UI, so the user can see that the light is turned off or turned on. Okay, so the controller for in a kernel level on the system, the controller is only one. If you had more sessions in this Blazor page, we will have a race condition. You receive a error from the .NET runtime, because you are trying to open multiple instances or trying to use a resource that is in use. Okay, is busy. So because of that, is very cool had this feature here, this singleton, because we are accessing and made the match between the pins and the controller of this GPIO on's time. And all the sessions that we will open our page will access this reference. And what a cool thing, let's show you the page index. This is the page that is on our screen. Okay, so we had the HTML here and the injection of the dependencies of our services. So I'm using here the GPIO device services as GPIO. And one cool thing is in my service here, I have this notify data change event function task. Okay, so I have this public event here, and so I have properties here to change the LED state. So when I change the state of my pin, if I turn off or turn on this pin, I check if this notify data changed and dispatch the events on the list. So in my page, I have to subscribe to add the page, add the on notify data change here. So when we change in a session in a local or remote UI, this event will be invoked and will check the state of our pin, and you change state here of our color of our button for turn on or turn off. This is very cool. This share services, instances, and this notify architecture. Other tips about, I'm using the same for the light sensor here. Unfortunately, we don't have this already implemented on the .NET IoT project. This will be good to contribute back with this implementation for access what we call IO devices, that is analog signals, that reads analog signals on Linux. So the same I'm doing here. I have the service that is only a singleton. Oops, here. So services are the singleton, the LDR device service. So all the sessions will use the same. And I have here a thread running each 1 second, and each 1 second we will notify these changes. And the page here we have another on notify data change for LDR. So every 1 second we will receive this to change your donut. And the donut I'm using here, this is very cool too, because we can write JavaScript. We can, the framework, the UI framework that I'm using here, that for access to .NET values, we can write JavaScript. We have to write JavaScript. So I have to write some function here to change the value of my donut, the level of life, the light, and to the color. So here, when I invoke the change, I run to the new value that we receive from the LDR level percentage that is injected here too. Okay. So this is the main tip for the embedded devices in Blazor. This is very cool because we have a controller. This controller had to be accessed once, and so we have this feature added a singleton to add this GPU device service or other services that have to access directly some piece of hardware. Okay. What more? I'm using here the main. Oh, sorry. I'm using here to add scoped. As the singleton, we will have an instance of this service once for all the sessions. But using this scoped, we will have this instance, a new instance for all these sessions. If I had an instance for my local UI and an instance different with new values for my remote UI. So I'm using this only to exemplify this kind of feature. I made here on header title to change. Let me. You can see here. It's a bit. You can see here the title. This title is shared between the pages. Okay. On the main layout Razor page. Might open here the main layout. Share it, main layout, and here. So I'm injecting here the page title service, okay? On the startup, I'm adding as the scope, so I will get a new instance for every session, okay? So when and here, page title, header title, okay? So in the index, for example, the page title, header title is on the initialize. It's not on the initialize. Where's this guy? Oh, it's here on after render. Okay, no problem. So we had this guy here, and this guy will share this header title will put the title of the page that is on focus on the application. So you can see that we are changing the shared content, but this not change on the local UI like the buttons. Okay, because this we are using with the scoped, not with this singleton. Okay. I think it's that. It's it.
So it's I'm a really fan of Blazor. I'm testing Blazor since like 3 years ago already, even before it was incorporated to .NET platform. And in my opinion, Blazor has a great potential to be used literally everywhere. And one thing, one specific point of .NET Core that I think it's really important is the cross-platform concept. It's not only about run the same application in multiple operation systems, but it's to be able to run the application everywhere in multiple devices as well, like not only in different operation systems. So, and because of that, it's this demo, it's pretty important to the technical community, because I'm not seeing Blazor being used largely, uh, even as a proof of concept for IoT devices or implementations like that. So thank you for your presentation. It was really interesting, and I think we deserve an extra talk to in this talk when that is in production, because it's a proof of concept.
Yeah. Yeah, we are evaluating this because we had some customers that coming from the Windows Compact. So I think Microsoft is not maintaining anymore the Windows Compact. So these guys has to migrate to Linux or Windows IoT. So we are trying to make tools and make these evaluations and things for our customers made a decision from migrate.
So this presentation will be available to everyone in CaquiCoders channel. It's we are getting used with online events in English. This quarantine times was a great opportunity to do this kind of thing. And thank you, Mateus and Lucas, for the presentation. Um, could you please, Mateus, share again your contacts?
Oh yeah, it's the next slide.
Okay.
my
So
GitHub, LinkedIn.
channel as well, like I think 3 months ago, more or less. Great content. I recommend to everyone to subscribe. And I have one last question for you, Mateus.
Okay.
If you can summarize the question in a simple answer, why Blazor for that?
As I said, we have these other platforms, for example, the GTK Sharp, the Mono forms, the Xamarin forms, but these guys are useful for the local UI. So maybe we'll have this duplicate work to make this for local UI and made a page on a web page or something for the remote UI. So with the Blazor, we can accomplish the two goals. And to the reactive content that we have with the Blazor components is one point of using it for the local UI to not the ASP.NET, for example.
All right, thank you, Mateus. It's getting to the end, this event. As I said, this will be available for everyone to watch later. It's not common for the CaquiCoders community to make events on Saturdays. So thank you, everyone. Thank you, Mateus and Lucas. See you in the next event.
Thank you, Alexandre.
Thank you very much, guys. See you next event.
Bye-bye.